Hello, everyone. My name's Kirill, and I'll be hosting today's session. We're MJC, Modern Java Community, and we're back after some hiatus. And today, we'll be starting today's series of tech talks with one of the most contentious, compelling topics regarding the orchestration, regarding the distributed systems, and we'll be asking and probably answering some of the questions. Can we master API orchestration today? These and some of the other questions are going to be answered, or maybe not, in today's session. Don't be shy. Feel free to post any comments, ask any questions you may have, and please use the chat. We'll be actually having a prize in the end of this tech talk. So the most compelling, the most interesting question will be judged by Slavik, and the winner will get a license to one of the JetBrains products. But that is in the end. For Q&A, we'll have special sections, but feel free to ask your question throughout the whole tech talk. And in the special sections, we'll have the Q&A chat and probably some discussion. We want to make this as much as we can discussion-based. So any ideas, any thoughts, any questions, you're welcome. With this, I'm passing over to Slavik, who's going to tell us more about orchestration, its caveats, questions, and problems. Over to you, Slavik.
Thank you, Kirill. And hi, everybody. I'm very glad to be invited on this Tech Talk and expecting a lot of interest in the topic. As today I'm going to talk about API orchestration and specifically patterns, how we can do it in Java. And I will be focusing on workflow pattern and present to you some opinionated implementation of it in the code, and will guide you through the internals and how it can be extended. And at the end, I'm expecting questions, a lot of questions, practically based questions about what are drawbacks of implementation of this pattern, which is most exciting part of any technology tech talks. So, couple of words about myself. So I joined EPAM as a junior developer, and throughout my career, I worked with many APIs and systems in distributed environments, and now I'm a senior solution architect working with APIs, integration patterns, and workflow processing. So today, I would like to start with presenting the case. So the case is built on real experience working with healthcare and financial industries. So second, we will be covering architectural topics, trying to understand how we are going to change the current architecture to implement new requirements. Then a little bit of theory about the workflows, so definitions, ways to present workflows, and implementation patterns, what can be used to implement workflow in the code. And then a little bit of AWS blueprints, how to handle workflows. And at the end, most exciting part about how we actually code the workflows, how it works, and interesting parts about extending it. And as a summary, there will be Q&A session where you will be having opportunity to ask your tricky questions and win the final prize. Okay, ready to get started? Let's go. So imagine we have a company, and the company is an insurance provider. And the company works with their partners through the B2B schema, exposes API to accept onboarding applications, and exposes SFTP communication channel to do it as any batch mode. Have infrastructure, a lot of infrastructure to handle these onboarding applications, have storages, workflow processing, and the same is on the retail insurance broker side. And insurance broker, this is the partner who works with the end customers, and they have all their own systems, and they simply integrate with our company and submit the application, the insurance application, to onboard the customer and activate insurance policy. And at the end, it expects some response in the API call. And we have got recent requirement which tells us, okay, so our onboarding process needs to be extended that the PDF form is generated and the form needs to be available online and offline for users to sign. Um, okay, let's move on. So uh, this is not a greenfield development, and we have captured already the baseline architecture. And architecture follows the orchestration saga pattern, and it consists of several domain services, orchestrator calls, and each domain service has its own transaction boundaries, meaning that inside the service, inside the domain boundary, we have a storage, and when the service gets the request, it is all or nothing in terms of transaction consistency. And so either we apply all the changes or roll back all the changes. And then orchestrator moves to the next step, calls the next service, and so on and so forth. And if something goes wrong with any of the services, the orchestrator will do the compensation action. So, an important thing to note here that everything is synchronous, starting from our API consumer and ending these domain services calls. So, from the general knowledge from the theory, we know that in distributed environments, we have basically two types of business transaction management, distributed business transaction management, which is orchestration and choreography. So left side is for orchestration, and as you see is that we have requests coming from consumer to our orchestrator, and orchestrator calls our domain services the way I described it before. And the interesting part happens when we have got a failure. So with some of the services, and because we have already committed our changes to storages for previous domain services, we need to perform compensate transaction and give a response to the consumer, which is still waiting until the transaction is complete, and the consumer, having the error response, should retry the whole operation. So on the right side, you have a bit different approach to the same problem of orchestrating business transaction. This is choreography, so-called. So I'm uh, sure you're well aware about this. Just again, focusing on the differences. So here we have asynchronous communication, that still our consumer talking to the first service, and the first service, after it's done, so it posts an event, and then or communicate with the second server through the communication asynchronous communication channel, and then so on and so forth. um, the problem comes again with the edge scenario, when the last business service fails, and that business service needs to have details about the business process we are handling, and to do the compensation actions. And the service in the middle can fail too. So, and here's the question: what is better? When to use what? And is there a single solution for this business transaction orchestration problem? So if you know answers to these questions or you have your own opinion, please share in comments. Okay, let's move forward. And um, besides all of these architecture patterns we have captured, we already know non-functional requirements which are important for our solution. First of all, we have identified the service quality metrics and following site reliability engineering practices. So we have two service level objectives. One is availability and the second is latency. So here, orchestrator calls up to 10, maybe more domain services, and availability target is 3 nines. And uh, the interesting question here, what should be availability of every service out of this 10? That availability of the orchestrator is 3 nines. So, and do you think that availability of 3 nines is a big number or is a small number? So is it hard to be achieved or it's not a big deal? So share your thoughts. And the second thing is about latency. As we have synchronous orchestration, synchronous calls from consumer, so we have this target as 30 seconds consumer can wait for response. But what if we have failure and we need to do something about it? So what kind of error handling we can implement? So obviously consumer can do retry, but how many retries and how it affects latency? Or should we do retries in our orchestrator when we call downstream services, or should the consumer uh, do the retries? So these are all interesting questions about the current architecture. And we move to the target architecture. So thinking about these non-functional requirements and our new requirement, which we have got to generate the form and make the form available either online or offline. So we decided that, okay, we need to change the pattern. Instead of Saga pattern, we would like to go with this process manager and with workflow pattern. So process manager is basically a Saga with a state management, or keeping state within the orchestrator. Saga is basically about linear workflow, so step by step. Process manager can be non-linear and it keeps state. So, and also with the workflow, we get the state machine definition. And we also have this state management. Workflow manages states and decides what could be the next step. And additionally, so we changed our communication from being synchronous to asynchronous in one case. So first, as you can see, we post the application through the one endpoint. So and endpoint responds immediately whenever we validate it and accept the request. And second, the consumer can periodically poll our orchestrator asking for the status of this application transaction processing. That's why we need state. So, and you see in the black box of orchestrator, we have workflow, which is a component, and we introduced our synchronous queue to increase reliability of our processing. If orchestrator goes down, then queue will keep our processing messages. And we also have state to actually respond to consumer if they would like to know where we are at with the application form processing. And work item is handled by the handler, and handler synchronously call domain services uh, as as workflow needs to move to the next step. This is the target architecture with workflow pattern and process manager pattern. So Kirill, maybe we have questions coming from audience. Okay, let me look.
Hello. So how are you doing so far? We have one question. What if compensation action fails itself and retries fail too?
Um, yes, that is a very possible situation, and that's why orchestrators become so complex. So if compensation action fails, it means that most likely something disastrous happening, and we need a human interaction. So usually it's handled the way that we post message to some notification channel, and some business operations team addresses this kind of problems.
Not that easy. Yeah, no easy answer. Next, we have a column. Given 10 dependent services, 3 nines is a high number.
Yes, it is. It is. I have the same impression. So 3 nines is a high number, and the situation gets uh, worse if you start thinking about how many nines should have your domain service that to support synchronous orchestration of business processing services or orchestrators. So that's the question. So think about it. And in real situation, I can share that these synchronous orchestrators can exist in because they are simpler. So if we have failure, we reply to the client with the error, and client does the retry, and that's easy handling solution. And even if, let's say, we declare 3 nines, so in reality uh, it could be a little bit less. So 3 nines, this is a big ultimate number after many iterations. But if it is 9 9 and the 5, so business can survive with that number. So this is not like they declare, okay, 3 nines and that's it. Do it, deliver. No, we always can negotiate and show that, okay, so here we have failures. In that time frame, we do not have failures. Maybe it is not 3 nines. So this is negotiable. Okay.
Yeah, thank you, Slavak. We have a comment. The target architecture might be implemented with temporal I/O. Have you heard
Yes.
about that? Mm-hmm.
Yes. That's one of frameworks I'm actually looking into. So at the end, I have a big summary section where I am mentioning about different orchestrational frameworks. Temporal IOs is one of them. And I also encourage you to look at Dapper, which is coming from Microsoft and which is distributed also actor management framework and workflow management server framework pops up. It uses sidecar pattern, and sometimes it's easier to implement. The problem with temporal IO, that is enterprise-wide centric system. So it requires DevOps team to operate in. It requires certain processes around make it uh, usable in the enterprise. I would say that's not like one single team can decide, oh, let's go with temporal IO, and after 6 months we have the temporal IO. So here my focus is about, okay, how we can do improve our API orchestration with the workflow pattern, and how we can implement the workflow pattern knowing all its pros and cons.
Thank you. Another question, slide 8, how to add prioritization, how to avoid latency increasing.
Uh, in the target architecture, I'm assuming, right,
Slide
Philip?
8, yeah,
Slide 8.
correct.
Yeah, latency. At the end, I have the real demo of this API. So this API works, this orchestrator work. You can see difference in the latency. So here, the pros of this approach that basically we decoupled consumer from the latency of downstream services. So consumer immediately gets response that, okay, we accepted your application, stay tuned, uh, fire periodical get requests to get the state. And if domain service fails, handler can can actually fail the message, the work item coming from the queue, and then next time, so it can reprocess the item again. So that sounds easy. I'll explain what are cons of this solution. So of course, we are increasing complexity here. You see, if we just simply calculate number of logical components we introduced, so it's bigger than before. And this is the measure of complexity. And we are raising complexity because we would like to improve our non-functional requirements. So we would like to improve availability, we would like to improve latency. And with this architecture, so latency availability will be improved. And additionally, we have one new requirement, which is about generating a PDF form. So we are extending our uh, business workflow with the new step. So we have workflow as a pattern in the code, and we have workflow as a business architecture concept. Hoping I answered the question.
Thank you. Another one, how to sync the orchestrator state in different regions to get 3 nines or more.
Yes. So multi-regional failover is a different topic, and of course, so for business critical processes, especially in financial industry, we need to think about these architectures, and that's actually a wider topic, a little bit out of scope of this presentation because we would like to focus on the code. And we started with the architecture to give you a high-level overview what we are doing and why we are doing. So the actually this is active uh, multi-region architecture. So our database should be active in many regions, and our services is active. Of course, it costs money, but this is a trade-off. So either active passive or active.
Yeah, it probably deserves a separate session
Absolutely
on
separate
its
session
own.
and topic. And right now on my project, I'm actually implementing the this multi-region failover in AWS, and the CTO office of the customer introduced an architecture with enterprise health check, with cloud watch events, with Route 53 routes, which can be switched from region to region. This is interesting and well, a rather complex topic. So suggest to keep it for some other tech talk.
One more, are there any frameworks available to perform this orchestration pattern between different microservices in a plug and play mode?
Yes, Dapper. Yeah, temporal. Uh, yes, so we do have a different orchestration, but it's not so hard to build something by yourself. So this is steps and this is workflow. You can see in the code that well, there are frameworks also, but what you need to do what you need to actually to have is the correct approach of structuring your logic in your project within the classes. Because if you start without the structure, without the forward system thinking about your software architecture, components, classes, responsibility, etc. So it quickly becomes out of hand project. And I have seen this. This is a huge methods, a lot of ifs, blurry naming of classes, blurring responsibility, not a single responsibility of every within every method. constantly changing teams. So one team owns the service, and then second team comes and no time to do the Boy Scout work to cleanse the forest, and everybody you can talk to. So they are not happy about this project. That's why it's important to sit, think, and bring certain structure into your code, or even into the architecture. So here we started with the architecture.
Thank you. Another one, what is the purpose of state in Orchestrator?
Uh, State keeps well, basically, technically speaking, when you get the request get application ID, you see green text next to the error. So you actually need to say to tell the consumer, so what's the so where we are at with this application. So we have state machine, right, which is a kind of, I will explain it later, that how you can get this response quickly. So should you go to queue? Should you go to domain service to ask? So you can, and even more, you have several versions of workflow in the wild, if I can say. So today you have 4 items in the queue, and tomorrow you deploy new version of your orchestrator with new step generates the form, and you still have something in the queue, but with old version of workflow and new version of workflow, and where to get state. So that's why with this asynchronous processing, state management is required, but indeed it's a raising of complexity. Because post is asynchronous. Post application, it's just 201 accept, and then get gives you status of the application. And on UI, you have this spinner, and instead of endlessly waiting for response to come, this is one pending HTTP request, right? So you can do periodically polling. Let's say you are going to the underground station, and then you lost connection, and you still have this spinning. I cannot imagine someone will be submitting health insurance applications during this road trips, but still.
Okay, helpfully it answered it. And one more. In a distributed system, individual components might go down separately without failing the whole system, only affecting some of its functionalities. How do we calculate system availability in this case to see if we're meeting 3 nines availability or not?
Yeah, this is about synchronous orchestration, correct. So measuring of it. So let me bring this slide about SRE availability. Right, we have service level objective. We should have service level indicators, and indicators is a measurement and of successful, in our case, successful API calls. So we measure availability of this onboarding orchestrator service, how good it responds to consumer. So how many 500 responses we have, and the same with downstream services. Every service monitors SLO availability, and there are systems of doing that, supporting this SRE methodology, automatically calculating SLO and tracking SLOs. This is part of the game. So, and even more, the team who is delivering the orchestrator, who is responsible for this domain, is usually responsible for support and meeting the SREs and SLOs.
Okay, let's have one more and continue. Could you please recommend the most useful resources for beginners seeking to learn about API orchestration? Thanks in advance.
Microservices.io, and one book, Learning Domain Driven Design. And I will write in comments these books. So there are actually, well, two of my favorite books I recommend to read. And after you just, well, get tiny details here and there from the streams like this, and those books give you really good theoretical understanding about the topic, the orchestration. And most importantly, so go to the project with the orchestrator, feel it by yourself, so look into the code, so work a couple of sprints and see how hard to understand the orchestration logic from the orchestrator. So that's most important personal experience.
We can actually include the list of materials in the feedback form, or possibly send out a separate list. So that is to follow.
Yeah, general advice: one or two sources, and stick to it and read from the start to the end, and then you can tell that you understand the topic from best persons in the industry. Okay.
Okay, let's move forward. We have some questions, but let's continue with the questions at the in the
Yeah,
end to
at
make
the
sure we
end,
cover.
we have this. And guys, thank you for so many exciting questions. So thank you for staying focused. At the end, you will have time to ask them again, and we still have coding part, which is most exciting. Okay, so a couple of slides, and I promise we complete with theory. So workflow pattern. So important thing, when we have identified that we are dealing with the workflow, right, to draw the workflow, to depict the workflow. And here you can see the so-called swimming lane diagrams. And so here you see the steps. So feel tired, make transaction, feel perky. And you see actors, so customer, barista, and you see certain actions performed by an actor and transitions from one action to another action. And you even see here um, some hard assets provided, like write details on a cap and mm, uh, similar things. So definition of workflow, let me stop here. So workflow constitutes a sequence of offline steps, I read it to be exact, involved from the start through the end of a working process to accomplish a task. So we identify we will deal with workflow. So we need to name our abstractions in the code, and definition of workflow gives us such naming and such abstractions. It's a sequence. We have step, we have working process, and we are accomplishing a task. So, and having that, let's move forward. And for our onboarding process, we have defined the state machine, which is an important artifact to produce and communicate this workflows within our team and within our stakeholders. So next in streamline diagram, so we have consumer orchestrator, which is non-technical actor, and domain services. So consumer submits the application, then orchestrator have has three steps: validate business rules, enrich application with some additional data from domain services, and prepare the form. And then consumer can sign the form, and this is success. This kind of diagrams should be written in business understandable language, and usually they come from product owners and from business architecture. So, and we do have one requirement: generate PDF form to e-sign or post through the ground post. Okay, so and having all that, we are moving to the moment we need to start implementation. So here are concerns. So first of all, which abstraction to use? The common glossary, uh, well, for communication and for naming our classes. So, and should we name this as events or messages, maybe comments, maybe actions, maybe work item? So what are differences? Which name we should choose? And then, okay, we have queue in our target architecture. So how many queues for workflow if we have, let's say, 5 steps of workflow? So should it be one queue or many? Two? So, and we also need to implement at least one delivery whenever we deal with asynchronous processing and with queries. So it's almost always at least one delivery. So it's a safe assumption to make and to code. And idempotency also. So because of infrastructure favor, sometimes we can get our messages twice, and we should have the ID within the message, and then we can see, okay, we have processed this message already if we are making changes, so ignore it. And concept of unit of work, when I was talking about all or nothing within domain service with the storage, this is unit of work. So meaning, so we have unit of work within the domain service, and it's committed or not committed. And again, storage we have discussed. So retry, we also discussed that we need to implement retries because infrastructure is not reliable. So, and even with this approach, when we switch to asynchronous, so we decoupled our consumer from the calls to our downstream services, we still need to do retry on our handlers. And so we still need to have the dead letter queue because we have one queue, and if messages by any reason are not processed in defined time frame, then they should go to DLQ. And one more question. Okay, we have queues, we have events or messages, and do we need schema for that? Like Evro or other similar systems. So I'll answer some of these questions at the end. You can also think about possible solutions. Okay, and so one more thing I would like to call out is old catalog uh, of enterprise integration patterns. So this is a great source of incitements, and here we will be using router message queue, dead letter queue, and we will be also using routing sleep and request reply. So I'll be talking about these patterns more when you see code. So I still need 10 minutes for your questions and 10 minutes for the code. So even if it sounds like an old catalog of patterns, and the book is really huge with these patterns. So if you just come to these materials on demand, ad hoc, it's not so big and it's still useful. There are systems around for many years like implementing these patterns. I worked personally with JBoss Fuse, OSGI, Apache Camel, and Spring integration. For some cases, they are cool. For some cases, they are not cool. So especially in microservices environment. So I will not be speaking about the systems, just to mention it. Okay, so now we still need to deploy this somewhere, and for our case we use AWS, and for the code I also used AWS, and our AWS architecture on the right side. So we have LB, SES service, and SQS. This is as simple as it possible because we have the we have the baseline architecture which already deploy Lysect. However, so we can still use managed services for workflow processing in AWS, and one of them is step functions workflow, which is really cool. They have the state machine definition, so step functions can call lambda CCS for long running tasks, publish messages to SQS. You don't need to write code for that, and update your state in DynamoDB. So this kind of processing can be really easy done with these step functions. And they can also be invoked through the API gateway in synchronous and asynchronous manner. So response can be provided to the consumer if they need to. So uh, really encouraged to think about it too. Okay, so and one pattern we will be using, this is request reply. So because we have requirement that we need to return the form synchronously immediately to the consumer. So maybe because, well, it is an intermediate solution, interim solution, so they cannot change their part to have periodical polling from UI, and they need simply to get the form right now. And this request reply to connect the asynchronous vault with the synchronous vault, and it uses a temporary queue concept. And in AWS SQS, we have virtual queues, and AWS SDK for Java supports this virtual queues and supports these request reply patterns. And in Spring, we have only SQS with listener, which doesn't support the temporary queues. And the flow is like that. So producer posts the message having the attribute reply queue, and producer blocks the thread waiting for the response. Then the message goes to the request queue, consumer processes it, extracts the reply queue URL from the attribute in the message, and responds back to reply queue. And in case of AWS SQS, this is temporary virtual queues. And then producers waiting for this response, unblocks the thread, and responds back to the consumers. So there is some catch in this pattern, request reply. So, and this is puzzle for you. So find this catch. So there is a corner case solution for request reply, which is, I would say, uh, greatly influence consumer experience. So it can break the system really easily. So imagine producer submits the message with reply address, blocks and waits. Consumer gets the message, does the work, and reply to the reply queue to the producer. So in this interaction, there is a catch. Okay, moving forward. Okay, that's it. So we are ready to jump into the code, and we will be implementing workflow pattern with request reply and generation of the form. So let me switch to the IDE. So here, structure of our project. From high level, it looks really easy. So we have transport layer, which is inside message package. We have onboarding, which is implementation of our workflow, and we have workflow base package, where we have base workflow abstractions, and we have our incoming controller, which is here in resource package, and controller is really simple, really lean. So it simply, you see here, we have workflow provider. So it gets the workflow. Uh, we have projection. So binary Boolean attribute saying, should we wait for response or should we not wait for response if our consumer is interested in reply or not interested in reply. So we get workflow instance, we start workflow. So, and here we use the action synonym of a work item. So this is work item, this is something going from the step by step through the workflow. And work item, I will show you a bit. So has some additional attributes like routing, sweep, payload, and stuff like that. And here, so we get the reply from workflow, and we send the response. And transport layer here, so you see, well, start from the model. So here we have the request. So this is request message, and it has workflow ID. It has request context. In our case, this is just about the user. And here we have routing sleep. Routing sleep, this is important patterns. So routing sleep is basically defining steps of our workflow. So, and it means that inside the message, we keep not only the state of workflow processing, not only the payload, the application form, and we can have a history of application forms, a history of processing within just the message. So at every stage, we know where we are at, and we know how we can roll back it. And in routing sweep, we basically define the route of our workflow processing, and it could be 2 steps or 3 steps workflow, 5-step workflow with additional form, and so on. And so going forward, we have right, and we have the message queue. Basically, we define the queue main name and getting the URL of the queue from the properties. Application properties. And one important component here, which is router. You saw the router from enterprise patterns, and the task of the router basically to post the message and to to route the message when it reads from the queue. So and when it posts to the message, so it basically gets the queue URL from the queue object and post it there. And it also keeps a list of action handlers here. And you saw in the pictures that every handler is responsible for one step of workflow, right? And so here's the send method simply. So either we wait for reply or we post and forget. And I'm going high level here, not going deeper into the code. Sorry, not so much time left. And route is the interesting method when we can pick the correct handler to process our step. And the task of the handler, I'll be speaking about it, is just get the incoming message and produce the reply message. So it will become clear when we go to the uh, um, uh, base workflow classes. So base workflow is about okay, so here you saw the start method. So here we get an action which is our payload, and here because this is base class, we don't know exact action. So we build the request message, and we basically compose the routes in sleep, and only workflow knows about its routes in sleep. So we can have workflow version 1, we can have workflow version 2 with different routes and sleeps, all in the wild. And here we set the action, and we post it to the router, and then router decides how to route this workflow. And here the onboarding. So onboarding, this is implementation of our onboarding workflow, exactly like I said. So if reply is required, then we basically request and wait reply. If not required, then we simply post and forget. And our steps like validate rules, enrich application, and submit application. So model here, so we defined states so of our workflow, or validate rules, enrich application, submit application. We defined our queues that we will be dealing only with one queue, and this is parameter the URL of the queue, which is in properties. And now we have the onboarding application, which is work item. So it has, sorry, onboarding application, this one. So it's basically fields of our application. In our case, we will be enriching with more insurance packages, and we have customer address, and we have broker information. This is specific to our onboarding workflow. And onboarding actions, this is work item. And here, so we have also information about the fields we require in the workflow. So, and handlers. So here we do the validation. So, and like I said before, so this is business rules handler. And here it basically implements action handler, so accepts our onboarding action and onboarding state. And the task of this handler is to handle the action and basically mutate the action and return the new version of the action. And here, not mutate, of course, this is copy, make a copy, and then return the new instance of the action. So here we just validated the rule and we updated the action. So next handler, so injects additional packages the customer has. So here we added packages. And here we just add so submit the application to the downstream service. So this is basically structure of the project with the workflow using the patterns we described. And um, still have a couple of minutes. So uh, here just a summary, that high level summary. We have request message, we have reply message containing the request message for the history. Reply message has the action, and workflow basically works with the workflow actions as a work item. So workflow uses the message router to submit messages to submit messages, and message router handles these messages through the action handlers, and action handler uses workflow step, and we also have routing step, which is inside routing sweep, and routing sweep inside the request message. So this is high level diagram built automatically with the IDE. And so next thing, I would like to show you how it works in reality. So I've recorded small demo. You see projection. So it means we need to get the reply. So this is our payload we provide to onboard the customer. And you see latency. This is the latency of synchronous processing. So we have processed it. This is our payload after processing, right? And we have this validation response, existing packages injected, submit response, and this is our original request. It has the routes and sweep, and we have passed all through these steps with validation rules, enriching application, submitting application, and the final most method is post. And so this is the final step of this routing sweep. And again, this is onboarding action. And so here, pay attention on the threads we will be working with. So we get the request right now. We started the workflow, and customer is still on the hook, waiting for response. So we posting and waiting for reply. So message received in the handler, which is another thread here. So then rules validated. Then next step is enriching application. We are posting, and then next handler gets a message from the or application for the processing. Then it posts to the next step, which is submit application, and then we are posting reply using the attribute we provided, and reply received to the original thread. So this is blocking and unblocking at the end, and workflow ends. And now another scenario when we do not provide the projection, which is simply fire and forget. So we posted the same application, and we received status accepted 201. And here, so let's see how the processing looks like. So we don't need reply. We started workflow, and we immediately ended workflow, and we provided the reply method. We simply validated the rules, and that's it. So, oh, we submitted this step with validation rules. Of course, all processing happens asynchronously. So that is how it works. And so we promised 10 minutes at the end for questions. I have another video recording how we can add a step there, but you can imagine, so we can add one handler, we can add one field, we can add one step to route and sleep, and when workflow starts, the gets a new form, a new version of workflow starts, it has a new route and sleep, new step, new handler, and everything works the same as before. Okay, so I'll skip this part, and now to the summary. So first, we have talked about process orchestration, which is a saga, process manager pattern, workflow pattern, and orchestration versus choreography. So we touched integration patterns, message queue, router, routes, and sleep message history. So we discussed with the request reply pattern, and we have there one open question: what's the biggest pros of this pattern? So, and this pattern needs to be used when we have synchronous vault, and they need to connect with a synchronous vault. And we spoke a bit about AWS blueprints, step function, good way to handling workflows in AWS. So SDK for Java supports of temporary queues and request reply pattern, and SQS listener in Spring. This is really easy, cool way to have the messages processing from the queue. Unfortunately, it doesn't support the request reply and temporary queues. So that's it. And now, oh, sorry. So I lost my presentation. Full mode. Okay, sorry guys about it. So I didn't realize it was when I switching from the slides or screens. Okay, so now questions and answers. So first of all, questions from the audience.
Thank you, Savak. Unfortunately, we have only 5 minutes left, so we'll try to answer as many questions as we can, but not all. We'll probably write a follow-up answering the rest offline. One question we have for Sega pattern, can orchestrator include any retry mechanism?
Yes, it should. So at least one retry for downstream service and expecting 3 retries from consumer. Imagine consumer could be UI application, could be B2B partner.
Thank you. What are the unexplored opportunities and potential impacts of integrating quantum computing algorithms into Java API orchestration workflow patterns to redefine efficiency benchmarks?
Um, well, hard to how well my answer is we can hardly compete with the complexity of the question, and I'll skip this one.
Okay. A question to slide 14. What if consumer never replies?
What if consumer never replies here? Timeout happens and producer returns the error. So that's the trick. That's the trick I was mentioning too, and that's the danger of this pattern. So basically, if you start thinking about it, it's not only returning the error to here to the consumer. It's about continuing of business process here on the right side, and so here imagine situation consumer will retry and you still have the processing here to the right side, and you need to detect if it is a new message or the message you are currently processing. So this is the puzzle I was thinking about, the puzzle question. Thank you for answering it.
Thank you. We have
Oh,
2 minutes
answer.
left, so we have probably some time for kind of outro regarding the questions you had on the slide, and we'll try to answer the rest of the questions offline. So let's have the outro and choose the most interesting questions for now from the list of answered.
Okay, so the question about what happens when consumer never replies. That was a tricky one. You stayed in the focus and you really followed the presentation, the pattern, and hopefully the code. So on my mind, this is the interesting one.
That was from Denise. Denise, I'll get in touch with you with the license. Thank you for your great question. We have a couple of more. We'll answer them offline, probably as a follow-up to this call. Sawak,
Yeah,
you wanted to conclude? Mm-hmm.
yes. We still have 1 minute, and this is my questions I left unanswered. So event versus message versus comment. Event, this is about something happened in domain-driven design and service boundary. When service does the work, it submits the event. Message is a base class, so usually it has whom this message is addressed to, but sometimes it's simply a base class. Command, this is something we need to do. So I also was mentioning work item and actions. Action is synonym of work item. Work item, this term, this name comes from a workflow pattern. This is something which moves from one step workflow to another step workflow. This is work item. How many queues for workflow? Usually for unit of work. So if we need to update something within a service, so it's not read-only, it's read-write, so it's a separate queue. We also can have queues based on velocity of processing, slow queues, fast queues. But the less queues, the better, the less complex system. Diffs, retry rollbacks, compensating actions. We discussed that, how to handle messages in DLQ. So whenever we have queues, we need to have DLQ. So either reroute with delay or logs the error in Splunk or in your console log, which ends in Splunk, and then someone from business operations should process these errors. Do we need schema checking for complex projects when we have many teams, when we have centralized message based middleware like Kafka? Yes, we need Avro. When we treat our messages as a contracts, separate contracts, what we can post, in which format we can post. So it saves time. So for all teams, it works for discoverability. Small teams, when everything is under our control, we can easily change the format. No, we don't need it. It's additional complexity, artificial complexity. That's it from my side. Thank you for staying with me. And well, I'm glad I shared my knowledge with you.
Thank you, everyone. In an hour, probably you'll get the feedback form. Please answer. It's gonna take probably about a minute, but it's very important for us to understand how to proceed further and how can we actually improve for next talks. You also get the list of materials, and we'll also try to answer all of the questions we had unanswered, unfortunately, due to time constraints in today's session.
Yeah.
Thank you, everyone. Thank you for having us, and thank you for joining.
I wish I
Thank you, Savak.
had more time for show you the code. And sorry, I feel like they're not all concept disclosed there. And this is again, this is a opinionated approach. This is I just wanted to tell you a story how theoretical knowledge can be used in practical coding part. Of course, you can code workflow in many other ways. One is better than other. Having objective reasoning, not subjective reasoning. This is very important. And thank you again. Thank you, Kirill, for inviting me.
Thank you, and thank you, Savak, and see you all in our next event. Bye.
Bye, guys.